Right, so Meta has spent this whole cycle watching other people own the coding agent. On the 5th of August that changed. Meta shipped Muse Code, a terminal coding agent, straight into a market Anthropic and OpenAI have effectively owned for a year. And the interesting thing is not that Meta showed up. It is which problem they decided to make their headline feature, because it is not raw capability. It is being able to see exactly what the thing did. Let's get into it. Now, follow a substantial task through this agent, because the architecture only makes sense once you see how it splits work up. It starts with a task big enough that you would not want to watch it. Muse Code is purpose-built for long-horizon, multi-agentic coding workflows, which is a deliberate positioning choice. Short tasks are already well served. The unsolved problem is the change that takes an hour and touches 30 files. Then it distributes the work across child agents that run in parallel. Parallelism is the obvious win for wall clock time, but it is also where these systems traditionally become a nightmare, because several agents editing the same tree produce conflicts nobody can untangle afterwards. Which is why each child agent automatically receives its own Git work tree. Your main working branch stays untouched while the agents experiment, and the isolation is managed for you rather than being set up you perform. Anyone who has manually juggled work trees will recognize how much friction that removes. And every action lands in a replayable per-session event log in SONL format, stored locally. Sessions persist across crashes, so a command called Muse resume picks the work back up. Every subagent spawned, every tool call, every steer and cancel is observable and replayable. So what does that buy you day to day? For concrete consequences. The first is that you can actually audit a run. When an agent touches your codebase for an hour unsupervised, the honest question afterwards is what exactly did it do? A complete event log answers that, and it turns a review of agent work into reading a record rather than reconstructing a story from a diff. The second is resilience. Long agent runs currently have a brutal failure mode, where an hour of work evaporates because something crashed. Persisting sessions and resuming them turns that from a catastrophe into an inconvenience, which quietly changes how long a task you are willing to attempt. The third is that your working branch stays clean. Experiments happen somewhere else by construction, so the failure mode where an agent half applies a bad refactor across your working tree simply does not arise. That is a structural fix rather than a prompt asking it to be careful. And the fourth is that intervention is first class. Steers and cancels are recorded in the log alongside the agent's own actions, so the record shows the collaboration honestly, including the moments a human had to step in and redirect it. Strip it back, and 3 choices define this release. First, it is a terminal agent installed with a single shell command. That is a deliberate bet that serious agentic coding belongs where builds, tests, and version control already live, rather than inside an editor. It also means it composes with everything else in your shell. Second, the model underneath it, Muse Spark 1.2, was co-trained with the harness from day one. Most agents wrap a model that was trained without any knowledge of the harness it would end up in, so training the pair together is a genuinely different approach. And third, be honest about maturity. This shipped in beta on the 5th of August, and it is built through the same Meta developer page that hosts the Muse Spark API. Promising architecture, real product, but not yet a thing with a long production track record behind it. Alright, let's consolidate what Muse Code is. Muse Code is Meta's terminal coding agent, released in beta on the 5th of August, aimed at long-horizon multi-agentic coding workflows and installed with a single shell command. It distributes substantial tasks across parallel child agents, and each one automatically receives its own Git work tree, so experiments stay isolated and the main working branch is never touched. Every action lands in a replayable per-session event log in SONL format stored locally, sessions persist across crashes, and a resume command picks the work back up where it stopped. And it runs on Muse Spark 1.2, a model co-trained with this harness from the start rather than wrapped after the fact. If agent tooling is your world, we take it apart regularly at Standarity.com.